This number, I don't feel like is that. Yeah, that's 20,160. All right, so I'm obviously thinking of something wrong here. So you know what I'm gonna do, guys? Let's just take a step away from something wrong with this example. I'll work on fixing it, and getting back to you about how to fix that. Let's move on to another example. So the example in the book, which should probably be easier to do here at the moment. So I'll work on fixing that example for you guys. We're on example 5. Well, that was example 5. Example 5 is the example that was broken. So something wrong with example 5 at the moment, okay? I need to fix example 5. Example 6. You have a password with 7 characters. All right, and you want an arrangement of 155 NUNN, because they live on 155 Nunn Road. The question is, how many different passwords are possible? And it says we're looking for permutations of the characters 15NUNN. So here the number of characters is 7. The K1 is 1. That's the number of ones. K2 is 2. That's the number of 5s. K3 is 3. That's the number of n's. K4 is 1. That's the number of u's. All right? So how many possible passwords? The answer is 7 factorial divided by 1 factorial times 2 factorial times 3 factorial times 1 factorial. All right, that's the number of distinct permutations here, possible passwords rather. And so that's 7 times 6 times 5 times 4 times 3 times 2 divided by 2 times 3 times 2. So we get the 3 cancels, the 2 cancels, and we're just left with 7 times 6 times 5 times 4 over 2 is 2. So that's 42 times 10. So the answer is there are 420 such passwords.
Why do you have 2
The 1, 2 is, so the 1, 2 is from the 2 factorial. 2 factorial is 2, and 3 factorial is 3 times 2. So, yeah. Now, I should also share with you the combination formula, but I think, well, let me write it down here. Well, I mean, I could write it down, but I don't have time for an example, so I think we should probably just stop here. So, thanks, guys. I'm a little bit behind. If I haven't extended the homework already, I will. I think I already did, though, so, yeah.